Hello and welcome to this lesson on functions. We're going to start this unit, being our fifth unit, is going to be all about functions. We're going to learn lots about them. But we've got to start out with figuring out what is a function. How do we know what a function is, what it looks like in all the various different forms? There's a bunch of different ways you could write or show or represent a function. So we're going to figure that out in this lesson. The essential question says, how do I determine if a given relation is a function? Okay, fairly straightforward. Did you know that a relation, so this word, just like we had here, says, how to determine if a given relation is a function? Maybe that word was confusing. Well, a relation in math it's a relationship between sets of values. In math, a lot of times we're talking about between the x value and the y value. So like when we make a table, there's usually some connection between the x value and the y value. They're related somehow. Well, that's all a relation is. The set of x values is sometimes called the domain of a function, and the set of y values is called the range. And then we'll talk about these a little bit later on in more detail. So for a further example of that same point, so in the set of points, if I have these 3 points, the 3, 2, 1, 3, 2, 1, these x values would be called the domain. It's the inputs. It's what you plug into the function. And the 4, the 8, and the -2 are the outputs, or the range of the function. So vocabulary. We've got 4 you can see here. The first one is a relation. So we just talked about this. So a relation, it's typically written as a set of ordered pairs. Now that set of ordered pairs can be shown as a table, as just a list of points. A relation can be shown using a graph. So there's a bunch of different ways you can show a relation. And the relation itself usually has an input and an output. This is what you plug into the relation. This is what you get back out of it. Well, typically we plug in an x value, so it's the x coordinate of a relation, and the output of the function is the y coordinate of the relation. And our ultimate goal in this lesson is to figure out if the relations we're looking at is a function or not. So a function is a relation, one of these x and y pairs, in which each input has exactly one output. And that's in bold for a reason, because that's pretty darn important for this lesson. Each input has exactly one output. That is the definition of a function, and we're going to show that multiple different ways throughout this lesson. So each relation has, or each input has exactly one output. And there's one more vocabulary word here. This is the vertical line test, and it is a test used to determine if a graph of a relation is a function. And this makes probably no sense to you right now, but we will see this, and I'll refer back to this definition when we're actually talking about the vertical line test here in like 5 seconds, because here it is. So we want to figure out from these graphs if this is a function. And one way to do this is the definition of a function. The definition of a function was each input, so each x value has only one y value. Oh, like a little messed up. Okay, that's the definition of a function. So I can say, well, here's an x value of -3. Does this x value of -3 have more than one y value? And the answer is no, it only has one right here. And I can make up some other random point. Does this only have one y value? Yes. Does this x point only have one y value? Yes. Now, another way we can do this, besides just kind of going and looking ahead every single one of them, is we have this thing called a vertical line test that is basically that exact same thing, but it's a little bit easier to demonstrate. So check this out. If I drag this vertical line across, we're looking to see, does the line cross the curve, the relation? Does it cross the relation at more than one place at a time? No, no, no. It's only crossing at one place, one place, one place, one place, one place, one place. By the way, this doesn't count, like the little arrowhead thing, and here, that doesn't count. Okay, the relation just keeps going. So this only crosses the relation at one place everywhere, which means this is a function. It also fits the other definition. Each x value has only one y value, and we saw that. Like this x value here, -2, only has one y value. This x value only has one y value. By comparison, letter B is not a function. And I'm going to show both reasons why. First, this x value has two different y values. An x value of 2 has a y value of, we're going to estimate, say, like 2.1 and -2. So this x value right here has two different y values. Right now, we can say this is not a function. If it fails at one point anywhere, the whole thing is not a function. And that's true a lot of different places. There's two y values for x value of 4. X value of 0, there's two y values. Okay? And you see kind of what I'm doing. Look, this is like that vertical line test. If I would just take my vertical line here and go, well, right here, the function doesn't exist over here. So that's okay. We're allowed to have places where the function doesn't exist. As long as when the function does exist, there's only one place where it's crossing the relations. Like here, there's crossing at two different places. This fails the vertical line test. It is not a function. Everywhere on here, it fails the vertical line test. Not a function. Over here, fails the vertical line test. Everywhere it fails. Okay? That's what the vertical line test is saying. It said it's used to determine if a graph of a relation is a function. If it passes the vertical line test, like letter A, meaning it's only touching the line at one place, then this is a function. If it fails the vertical line test, like here, then it is not a function. Okay? Okay, let's look at some other graphs. So letter C, I'm going to have you try that one. See what you can come up with. And then letter D we'll go through together. So go ahead and try letter C first. Pause the video. Do that one on your own. Function or not a function? And the answer is function. This is a function. Maybe I should put yes function. Yes function. I have my vertical line test I can use. So if I move him, he's only crossing at one place. He's crossing at one place. One place. One place. One place. That's good. All these gaps in between here don't matter. It's okay that it's not crossing anything. It's okay it's not crossing anything. But when it does cross, it's only ever allowed to cross at one place at a time. This is a function. Letter D. This is not a function. And I want you to see if you can figure out why. Why is this not a function? Where does it fail the vertical line test? If you were thinking right here, oh, I missed it, right there, not quite. It actually is passing the vertical line test there. I know a lot of you have learned about inequalities and at least the solid dot and the hollow dot and stuff. Well, the solid dot means that that point exists. That there's a solution, a value right there. But when you see this like open circle, it means a dot doesn't exactly exist right there. It exists very, very close to there. So having this is actually okay because it's not crossing a point right here. It is crossing a point right there. So this is only crossing at one place right here. That's allowed. This, on the other hand, is not allowed. Right here, if I can move my thing out of the way, there you go, see better. It's crossing at one 2 points at the same time. So right here on the y-axis, it is failing the vertical line test. This is why it is not a function from these 2 points alone. So the entire thing, the whole thing, is not a function because of these 2 points. Okay? It's okay that this function looks weird. It's called a piecewise function, where you see it's kind of like broken down into like 3 different little line segments. There's gaps, there's overlaps. That's okay. But right there, it is not a function. Okay? Here are 2 more for you to try. If you could please pause the video, try these 2 on your own, and when you are ready to continue, hit play, and we'll go through it together. All right, so let's see. Letter E here. You should have said that, yes, this is a function. Yes, function. That is a function. The vertical line test, my lines are horrible, but it only ever crosses at 1 point everywhere. It's never going to double up. That passes the vertical line test. That is a function. Letter F is not a function. My vertical line test, boom, fails, fails, fails. Let's draw that circle a little better. There we go. It's failing the vertical line test because this x value right here has 2 different y values. An x value of, what is that, 1, 2, 3, 4, 5. An x value of 6. When x is 6, I have y values of 3 and like negative 1.2 or something like that. So one input has 2 different outputs. That is not allowed, not a function. Now, we would like to be able to do the same thing, but without having a graph. Essentially, our job is the same. Will the line that we're looking at, will the relation we're looking at pass the vertical line test? And I don't really like these directions much anymore. We don't need to write a mapping diagram. By the way, this is what a mapping diagram looks like. It's 2 bubbles showing input, output, but there's more than one way of showing a function, like a table. It's a fine way of showing a function, so we don't need that. So we want to determine if each relation represents a function. So ignore those directions. So let's see here. Does this represent a function? Well, let's think about this. If I was to graph this, would this pass the vertical line test? I can make a little sketch. This is showing input of -2, output of -1. That is the point, -2, -1. Bum, 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 bum. Little sketch dot right there. That's him. This is showing input of 5, output of 0. That's the point 5, 0. Something like that. The last one is showing the point 7, -1. 7, -1. Would that pass the vertical line test? Why, yes, it would. I mean, vertical line passes here, it would pass here, it would pass here. Each input, -2, only has 1 output. 5 only has 1 output. 7 only has 1 output. So is this a function? Yes, it is. And that's what I do when I'm going through and figuring out if the thing I'm looking at is a function or not, is I'll make a sketch a lot of times, or at least I'll imagine the points in my head. I will list out my point that I'm looking for. Is there a single x value that has more than 1 y value? Letter B, for example. Let's look here. Do I have any x values that have more than 1 y value? Does -5 go to 2 different values anywhere? Well, no, because this is the only -5 input I have, which means he only has 1 output. In fact, none of these have more than 1 output. There's only one -3 with an output. There's only one input of 6, only one input of 5, one input of 0, which means this is a function. This would pass the vertical line test everywhere because I don't have one x value with 2 different y values. Now, letter C, on the other hand, fails the vertical line test. Letter C is not a function. I will tell you right now. Can you figure out where it fails the vertical line test? Where is the same x value have two different y values? It fails when x equals 4. That's where it fails, because look at this. I've got two x values of 4 with the different y values. If I would graph that, 1, 2, 3, 4, 1, 2, 3, so 4, 3, 4, 2. Those are those 2 points right there. That would fail the vertical line test. I have 2 points directly vertical of each other. One x value has two different y values. This is not a function. It fails. All right. I would like you to do letter D. If you could, please go ahead and pause the video. Try letter D on your own. Is this a function? Yes or no? When you're ready to continue and go through it together, hit play and we'll do just that. All right. Letter D is not a function. And let's make our highlighter good. Okay, so this is where this one fails. I'm going to highlight where it fails. Where does letter D fail? If you didn't highlight this yet, do that. Where does letter D fail? Well, it fails right here. I've got 2 inputs of 5, the same input, but with 2 different outputs. If I was to graph those 2 points, they would be vertical of each other. They would fail the vertical line test. This is not a function. And I encourage you, if you need to graph this, take a piece of graph paper and graph the points. If you have a graphing calculator, you can input these points in the table feature and then graph it. If you don't know where that is. Clear. If you go into the list and the stat, so second list. I don't want that actually. Stat. And I can edit. So I can actually go in here in this stat feature and I can type in numbers. So I can type in 1, and 2, and 3, and 4, and 5. And if I go here, oopsie, and type in the x values, 5, 6, 7, 5, 8. So now I've basically recreated this table in the calculator. Okay, in the graphing calculator, up here above, normally we'd hit this y equals to graph a line, but we don't want to graph a line. We want to graph these points. So we're going to hit second that y equals. It says stat plot. We're going to plot the statistics. We're going to plot those points. And we inputted the data under L1 and L2. So I'm going to click enter. And right now, that plot is off. I'm going to change it to on. And also it asks what type of things you want. So do you want a scatter plot, a line graph, a bar graph, a box and whisker plot, or a skeletal box and whisker plot, a regular box and whisker plot? And I can't quite tell what that one is. It's asking what are your x values and y values, which are fine because under stat, we put the x values under the first list and the y values under the second list. And then ask for which mark you want. Do you want a little dot, a plus, a box? I'm fine with everything that it has here. So now if I hit the graph button, you'll see boom, 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 boom. And we can see right here, it fails a vertical line test. Another option would be, not with this calculator, but with something more like Desmos. I could take out Desmos. I could add in a table. This one I know how to do. Add a table. And I can type those same values. So it was what, 5 and 1, I think. This is the worst part about Desmos. I have to keep flipping back and forth. So 5 and 1. So 5, 6, 7, 5, 8. 5, 6, 7, 5, 8. And this was 1, 2, 3, 4, 5. All right. Now we can see, boom, it fails the vertical line test right there. So let's keep going. Letter E. Let's determine if this is a function. I'm looking. Now, if you don't like this list view, it is okay to absolutely take this and go, okay, I like a table view. So the first one is the point 3, 6, -2, -1, -1, 4, 6, 4. That's okay to do that. So now we have each of these, it's just written as a table. And I can look. Do I have any of the same x values being repeated? No. Which means this will be a function, because I only have one of each x value. There's no way I'm going to have two different y values. Yes, this is a function. And again, you can take those points and graph them by hand on actual graph paper. You can use a technology tool like a graphic calculator or Desmos to check yourself. Okay, letter F. If you could please pause the video and try that one. Is letter F a function? What do you think? Make a table if you need to. The answer is, it is not a function. In fact, this fails the vertical line test everywhere. This table would look like this. Input of 6, output of 5. Input of 6, output of 8. Input of 6, 9, 6, 12. In fact, the graph of this would be boom, 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 boom. Like all of these points are just completely vertical of each other. They all have the same x value, different y values. This is a vertical line. It fails the vertical line test everywhere. Well, everywhere that there's values. Okay, this is not a function. All right, a little bit of problem solving. So it says Arnold recorded the minutes he typed and the number of words he typed in that amount of time. The inputs are the minutes Arnold typed and the outputs are the words he typed. Is the relation represented by the table a function? So is this a function, yes or no? And the answer is, well, yeah, it's a function. Because I was looking at my different x values. In a table, the first piece in the table is always the x variable. The second part is always the y variable. X always comes first. So do I have any repeated x values? 35, 25, 23, 46, 50? No. They're all unique, which means there's never going to be a place where there's two values directly over top of each other. This would pass the vertical line test. This is a function. Letter B. Lisa has the graph below. Which 2 points can be removed to make the graph below a function? Why did you choose the points that you did? So if you could please pause the video, highlight or circle or cross out or something, mark 2 points that you would remove to make this a function, and then just off to the side here, give a small little explanation on why you chose those points. Go ahead and pause the video and do that now. All right, so you actually, this is not quite a straightforward answer. There's choices. So you had to pick one of those two because those two are vertical of each other. They would fail the vertical line test. So you had to pick either this one or that one of those two. You also had to pick one of those two because right now they fail the vertical line test. So you could have said, I want to get rid of this one and that one. And that would have been okay. If you got rid of those two, the remaining two would pass the vertical line test and we would be fine. Or you could have chosen the top two or the bottom two or this one and that one, but it had to be one of those two and one of those two. And then why did you choose the points you did? You would say something like, well, it fails the vertical line test. The 2 points are vertical of each other, something like that. That I removed one of those because they're vertical, and so they would fail the vertical line test. The x value of 1 has 2 different y values, which is not allowed, and so by removing one of them, it makes it a function. Something like that. And summary. In your own words, describe how to tell if a relation is a function. You could talk about from a table, you can talk about from a graph, you can talk about from a list of points, you could talk about from a mapping diagram. Just in your own words, how do you tell if the thing you're looking at, the relation you're looking at, is a function. Go ahead and pause the video and put down some words. Okay? I would say something like, if it passes the vertical line test. That's like the main way to tell if the relation is a function or not, if it passes the vertical line test. If you're given a table, make a sketch. Sketch out, get a piece of graph paper and graph it out, or use something like Desmos or a graphing calculator. Okay? So there's lots of ways to tell if it is a function or not. Okay? Thank you so much for watching the video, and until next time, toodles.